Hello and welcome to another geometry lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 9, Lesson 10 on placing a circle in standard form. Now today is really a follow-up lesson to Unit 9, Lesson 9, where we looked at equations of circles and we specifically said, well, if an equation of a circle looks like this, then we can identify its center and its radius. Let's start off with a little review on that. All right, equations of circles. In the last lesson, we saw how the distance formula could be used to create the equation of a circle in the coordinate plane. When given this equation, we must be able to identify the center and the radius. So let's do a little review on that before we move on. Exercise number 1. Determine the center and radius of each of the following circles. All right, well, I'd like you to pause the video right now. This is what we did in the last lesson, and if you haven't seen the last lesson, you really should go back and take a look at it, otherwise you're going to be lost in this one. So pause the video now and identify the center and the radius of each one of these circles. All right, well, for letter A, whenever we have an equation of the form x squared plus y squared equals a number, then this is a circle whose center is at the origin. All right, and then this number will always be the square of the radius. So the square of the radius is 100, which obviously means the radius is then 10. All right, now if we don't have a circle that has this form, but has the form of x minus a number squared plus y minus a number squared equals a number, then the numbers that are subtracted are the coordinates of the circle's center. So in this case, the center of the circle is at 5, 2. All right, the radius squared is again 36, and therefore the radius is equal to 6. All right. Now finally, if we have a situation where we're adding numbers to x and y, then all we have to do is change the sign on that number to better think about how we're subtracting. So we want to think about x plus 2 squared as being x minus negative 2 squared. So in this case, my center is at negative 2, positive 11, and my radius is equal to the square root of 1, so my radius is just equal to 1. All right, and that's pure review from our last lesson. If you're looking at this and you're like, I have no idea what he's talking about, you need to go back and take a look at that lesson before you move on. All right, now, completing the square. Now, equations of circles are not always immediately placed in this form. If they are not, it is very difficult, if not impossible, to identify the center and the radius. We can use the process of completing the square from Algebra 1 to place equations of circles in the standard form, also known as center-radius form. First, a review of completing the square. So in Algebra 1, you should have spent a considerable amount of time solving quadratic equations by a method called completing the square. And that's what we're going to have to use in order to put circles in their standard or center radius form. All right. Now what we're going to do here has nothing to do with putting circles in those forms or has anything to do with circles whatsoever. But I wanted to review how we complete the square, right? Because those same steps we're going to be using. The difference is here we're going to be solving these equations for the value of x, whereas in the situation where we're completing the square to identify the center and the radius of a circle, we're not solving for x. Anyway, let's take a look at exercise number 2. Solve each quadratic equation below by using the method of completing the square. All right, so let's talk about how that's done. I'm going to write this equation just a little bit bigger so that you can see it a little bit easier. All right, so first things first. The method of completing the square only works if the leading coefficient, the number that's multiplying the x squared or y squared, is equal to 1. All right, which in both of these cases it is, right? It's 1x squared here, it's 1x squared there. Now, what we do, if we've got that situation, is that we take a look at the term that's multiplying x, or the constant, that's multiplying x to the first. We take that and we find half of it, right? So we do 10 divided by 2, which is 5. And then we take the 5 and we square it and we get 25. Now what do we do with that number 25? Well, what we're going to do is we're going to add it to both sides of this equation. All right? So we're going to have x squared plus 10x plus 25 is equal to 39 plus 25. Obviously, if we add something to the left side of the equation, we must add it to the right-hand side of the equation to simply have the equation balance. Now, if we did that correctly, if we divided our b value by 2 and square it and add it on, then the trinomial that we have here will now be what's called a perfect square trinomial, meaning that it will be a trinomial that can be factored as a binomial squared. Specifically, on the left-hand side, this factors as x plus 5 times x plus 5, and this is just added together, gives me 64. All right. Now, obviously, x plus 5 times x plus 5 is x plus 5 squared is equal to 64. Now, we're going to go on and we're going to solve this equation because that's exactly what the problem asks us to do. But I will say, in terms of the work that we do with circles in a moment, this is as far as we're going to have to go. Okay, we're not going to have to solve anything. We just got to get to this point. But if we wanted to solve this, then what we would do is we'd take the square root of both sides, and we'd get x plus 5 is equal to plus or minus 8, right? Because the square root of 64 is either a positive 8 or a negative 8. So I'd get x plus 5 is equal to 8. X plus 5 is equal to negative 8. Subtract a 5 from both sides, and I'll get x is equal to 3. In this case, subtract a 5 from both sides, and I'll get x is equal to negative 13. All right. And you probably did that so much last year in Algebra 1 that you were just sick of it. I know I was sick of it after making all the videos on how to do it. All right? Now, that being said, okay, what I'd like you to do is I'd like you to solve this equation in exactly the same way. Now, you might say, but wait a second, this one's got a negative 7 hanging out over there. Fine. Add a 7 to both sides to begin this process and see if you can solve this equation using completing the square. All right, well, I'm going to move my calculator, which I'm going to want a little bit later on over here. Move this over here, and let's do it. Give myself a little bit of extra space, okay? First thing I'm going to do is move that unwanted constant to the other side. That's going to be x squared minus 6x is equal to positive 7. I take that number that's multiplying x, that's negative 6. I divide it by 2, I get negative 3. I take negative 3 and I square it, and I get positive 9. I will always get a positive number when I square. So I'm going to get x squared minus 6x plus 9 is equal to 7 plus 9. This then factors into x minus 3 times x minus 3 is equal to 16. By the way, notice, right, both here and over here, that the number that went into both of these parentheses, right, minus 3, positive 5, was that half of the b, right? Half of the 10 was positive 5, positive 5, positive 5. Half of the negative 6 was negative 3, negative 3, negative 3. Again, right at this point, I can take these two things and write them as x minus 3 squared equals 16. Take the square root of both sides. I get x minus 3 is equal to 4, and x minus 3 is equal to negative 4. Add 3 to both sides. I'll get x is equal to 7, and add 3 to both sides of this messy looking thing, and I'll get x equals negative 1. Now again, the purpose of today is not particularly to have you relearn how to solve quadratic equations by completing the square. It was mostly to review the idea of taking half of that b term, right, squaring it, and adding it on to both sides of the equation, and then factoring that resulting trinomial. All right, but given that, we are now ready to work with circles again. Placing a circle in standard form. Now that we've reviewed the basic algorithm of completing the square, we can use it to help identify the center and the radius of a circle that is not already in standard form. So there's no need to do this if we have circles written in the way that they were in exercise number 1. But let's take a look at a circle that doesn't look like that. Exercise number 3. A circle has an equation shown below not written in standard form. X squared minus 4x plus y squared minus 8y is equal to 5. Letter A, use the process of completing the square twice to write this equation in standard form. All right, this is really cool. So what I'm going to do in this situation is I'm going to complete the square on this binomial, complete the square on that binomial, right, in order to turn it into something that looks like a circle in standard form. So here we go, right? In the first case, right, I've got a -4 multiplying the x, right? And of course, if I do -4 divided by 2, I get -2. And if I do -2 squared, I get 4. So the first thing I'm going to do is have x squared minus 4x plus 4. All right, then here I've got -8 divided by 2, that's -4. -4 squared is 16. So I'm going to have y squared minus 8y plus 16. And then, of course, whatever I've added to the left, I must add to the right. Right? So I've added 4 in order to make this a perfect square trinomial. I've added 16 to make this a perfect square trinomial. And then I've added both the 4 and the 16 to the right-hand side just to keep my scales balanced. Now, I can think of it as factoring this. That's going to be x minus 2 squared, right? And y minus 4 squared. And then 5 plus 4 plus 16 is 25. There we go. And now I've taken an equation of a circle, real messy because of all the parentheses up here. But I've taken this equation of the circle that is not written in standard form, and I've now written it in a form where it should be, in theory, easy to figure out the center and the radius. And in fact, let's do that in letter B. What are the center and the radius of this circle? All right, why don't you pause the video right now and go ahead and write those down. All right, real nice, right? Because I've got subtraction in both of them. Right, so my center is going to be at 2, 4. My radius will be the square root of 25, which is equal to 5. So there we are, right? Center at 2, 4, radius equal to 5. And finally, something that you have to do every once in a while, right, is actually graph the circle in the coordinate grid. Now this can be a little bit tricky, and you definitely have to use your compass in order to do so. But here's what I like doing, right? I've got a center at 2, 4. So I'm going to plot my center, right? I then have a radius equal to 5. And what I like doing with that is I like plotting what I call the 4 cardinal points. So I'm going to go 5 units above my center, 5 units below, 5 units to the left, 5 units to the right, and I'm going to plot those 4 points. It's going to be simple enough. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. I just kind of like to have those, and then what I'm going to do is I'm going to take my compass, put the sharp point at the center of the circle, as I always should, extend it out, and that didn't even come close. Why not? 1, 2, 3, 4, 5, and that's because this one I plotted 6 units away. And it's still not all that great because of the limitations I have with my compass. Limitations I have with my compass and apparently with my counting ability on this one. All right, but I more or less have it. I'll have another shot at doing this later on in this lesson. So I'm going to get it right the second time. All right, hopefully. I probably shouldn't boast yet. Okay, so let's get some practice on this. Now the method for writing the equation of a circle takes practice and relies on completing the square oftentimes twice. Often twice, not always, but often, okay? So let's take a look at some of those. And there's all sorts of different things that can be thrown in that are challenging, like, a fraction here, or equations where there isn't a 1 multiplying the x squared and the y squared. But let's get some work on it. All right, so let's take a look at letter A. For each of the following equations of circles, place it in standard form and then identify its center and its radius. Letter A, x squared plus 8x plus y squared minus 4y is equal to -16. Now this is the one that's the most like the ones that we were just doing. Now again, you take it one step at a time. So, right, when I'm looking at the x terms, my b is equal to 8, right? So I just take my b, I divide it by 2, I get 4, I take 4, square it, and I get 16. So I'm going to have x squared plus 8x plus 16. Then when I look at my y, I've got -4 divided by 2, that's -2. I've got -2 squared, that's equal to 4, right? So I'm going to have plus y squared minus 4y plus 4. And of course, I ran out of room. So maybe I'll just move these over here real quick. I need to add both of those to this side. That's going to be negative 16 plus 4. Okay. So I've done my sort of completing the square on both of those two binomials involving the x and the y. That means I can now do my factoring. All of this will factor as x plus 4 squared. This will factor as y minus 2 squared. Here, my negative 16, my positive 16 will cancel, leaving me with a 4. And at this point, I've got my circle in its standard center radius form. Easy to identify the center, right? My center now is at negative 4, positive 2, and my radius is the square root of 4, which is equal to 2. All right, simple enough, okay? Now, let me move this out of the way over there, okay? Now, when we look at letter B, right, the only thing that's even slightly different about letter B versus letter A is the fact that you have a fraction over here. See if you can overcome that difficulty, though, and see if you can work through this one, identifying both the center and the radius. Pause the video now and take a few minutes. All right, well, yet again, let's start with the x's, right? With the x's, I've got my negative 10. I'm going to divide it by 2. I'm going to get negative 5. Take my negative 5, square it, and I'm going to get 25. So first things first here, I'll have x squared minus 10x plus 25, plus, for my y, I've got negative 6 divided by 2. That's negative 3 squared, that's 9. So now I'll have y squared minus 6y plus 9. And now I have no room, so move these out of the way. Try to move these out of the way, and I'll have negative 15 fourths plus 25 plus 9. We'll deal with that fraction stuff in a little bit. Now let's do our factoring. I'll have x minus 5 squared plus y minus 3 squared equals. Now, this is not a course in 5th or 6th grade math, okay? You've got to be able to deal with this. One of the nice things is that on our TI Inspire calculator, it's really a piece of cake to put in 15 divided by 4, or you could use the fraction button if you want, plus 25 plus 9, and the default setting on your calculator is to give you your answer in terms of a fraction. Now, I realize that that's really, really tiny, but that fraction says 121 fourths. Okay? And now we've got our equation in center radius form. I know that looks a little bit scary, but we'll get to it in just a second. The center is still easy, right? The center is 5, 3, no problem. And the radius is equal to the square root of 121 fourths. Now again, one thing that's nice about square roots is that you can literally, if you're taking the square root of a fraction, you can take the square root of the numerator, which would be 11, and the square root of the denominator, which would be equal to 2. So I can get 11 halves as my radius. You can also just take your calculator and ask it for the square root of 121 fourths, and it will tell you 11 halves. All right, so again, you've got that calculator option there just to feel confident about it. Okay, now there is one additional thing that you've got to be concerned about when doing these types of problems, because they're relatively easy. Let me just delete this so that we don't have it sitting there. And that's what happens if the coefficients on the x and the y squareds are not equal to 1. Okay, so in letter C we have 2x squared plus 4x plus 2y squared minus 4y is equal to 14. The method of completing the square will not work if the coefficients on the x squared and the y squared are not equal to 1. Now, just as a little aside, if you have a situation like that, and the coefficient on the x squared and the y squared aren't the same, if this was 2x squared and 4y squared, that's not a circle. All right? So they're either going to be both equal to 1, or they're going to be both equal to a different number, but that number should be the same. Now here's how you deal with it. Whatever that number is, you're going to divide both sides of the equation by that number. So if that number is 5, you're going to divide both sides by 5. If that number is 10, both sides by 10. Now don't forget, division distributes. Division distributes, division distributes. So in other words, I'm going to do 2 divided by 2, 4 divided by 2, 2 divided by 2, negative 4 divided by 2. Every single one of these coefficients is going to get divided by 2 because division distributes just like multiplication does. So I will get x squared plus 2x plus y squared minus 2y is equal to 7. And I can almost guarantee whatever standardized test that you will take will have a problem where you have to do this on it. It's obnoxious, it's unfortunate, but sometimes you just got to do it. And once you have it here, then it's exactly like problems A and B. Pause the video now and see if you can complete the square on this and identify its center and its radius. Well, this one's kind of interesting because we have a coefficient of 2 on this x and we've got a coefficient of negative 2 on this y. Now 2 divided by 2 is 1 and 1 squared is 1. So to complete the square on that one, we're going to have x squared plus 2x plus 1. Here, same thing. Negative 2 divided by 2 is negative 1. Negative 1 squared is 1. So we'll have 7 plus 1, 7 plus 1. Okay. Now the factoring. This will end up being x plus 1 squared. This will end up being y minus 1. That's a minus 1 squared. And of course that's 9. And now the rest should be easy, right? The center is going to be at negative 1 comma 1. And the radius, that doesn't look like an R. That looks like a funny square root symbol. The radius is going to be the square root of 9, which is 3. All right, that's that. Okay, one last problem. Why don't you go ahead and see if you can do the whole thing on letter D. All right, well, on letter D, you have kind of a choice that you have to make right up front. Do you move the 260 to the other side to make it negative 260 and then divide everything by 5? Or do you divide everything by 5 up front and then move the number over to the other side? And the answer is it absolutely doesn't make any difference. I'm betting that the majority of people chose to divide both sides of the equation by 5. So let's do that. And again, that division distributes, so 5 divided by 5 will be x squared. If you don't know what 70 divided by 5 is right off the top of your head, then you take your calculator out and it's 14. Right? And then I get y squared and then minus 4y. And again, if you don't know what 260 divided by 5 is off the top of your head, right? You just do that. And 0 divided by 5 is just 0. Okay? So we're right there. Now, what we certainly want to do is at this point, move that 52 over to the other side. Now, anytime that you move a number or an expression from one side to the other side of the equation, it always changes sign. Surely you know that at this point. X squared minus 14x plus y squared minus 4y equals negative 52. And now I'm off to the races, right? But it did take me all of that, right, to get back to basically something that looks like this. All right, so I had a couple steps just to get to where I was here. Now we can do the completing the square. Here we go. So I look at my negative 14, I divide it by 2, I get negative 7, I square negative 7, and I get positive 49. So x squared minus 14x plus 49 plus, right, this one, I've got negative 4, I divide it by 2, I get negative 2, I square it, and I get positive 4. So I'll get y squared minus 4y plus 4. And on this side, I have negative 52 plus 49 plus 4. Okay, we'll take care of that in just a little bit. Let's do our factoring. X squared minus 14x plus 49 will be x minus 7 squared. Y squared minus 4y plus 4 will be y minus 2 squared. And all of that sums to be equal to 1. Negative 52 plus positive 43 plus positive 53 is equal to 1. And now it's very easy to identify the center and the radius. The center will be equal to 7 or at 7 comma 2, and the radius is equal to 1. All right. So quite a bit of work on that, but the great thing is it's very algorithmic. Get rid of any coefficient other than 1 that's multiplying the x and the y by dividing it out from both sides of the equation. Move any lone constants over to the other side, and then complete the square on both the x terms and the y terms, and then identify the center and the radius. Let's do one last problem. Okay, exercise number 5. Solve the following system of equations graphically. Awesome. All right, so remember, when we solve a system of equations graphically, what we're looking for is the intersection point or points of the two things that we're graphing. In the first case, y equals x minus 1, we should be very comfortable with the fact that this is a line whose slope is 1 and whose y-intercept is -1. Right? So we could graph that right away and we could get it up there. But then we have a circle that we're going to have to graph. So maybe we'll take care of the line first, and then we'll come back and we'll take care of the circle, right? This is a line, a lime. How about a line? A line whose slope is equal to 1 and whose y-intercept is equal to -1. So I'll just plot that y-intercept, and then maybe I'll plot a few of the points and then use my ruler to really kind of get the rest of them. Real quick, let's get this out. We want to be fairly accurate with this, otherwise we could end up finding erroneous intersection points. All right, so there we go. There's our line. That should be a piece of cake. If you have to use your graphing calculator, of course you can, to generate a table of values or something like that. But we've got y equals x minus 1. And now we need to complete the square a couple times on that circle to figure out its center, its radius, etc. So why don't you go ahead and pause the video, complete the square a few times on this, identify its center, identify its radius, graph that circle as carefully as you can, hopefully even better than what I did previously, and try to find the intersection points. Pause the video now and take a few minutes to do that. All right, well, let me just move my compass out of the way for right now. Here we go. We have x squared minus 12x. Take half of -12, we get -6. Square it, and we get 36. Y squared minus 8y. Take half of -8, we have -4. Square it, and we get 16. And then we have -27 plus 36 plus 16. Anyway. Here we'll have x minus 6 squared. Here we'll have y minus 4 squared. And here, I think I'll bring out my calculator real quick. -27 plus 36 plus 16 gives me 25. Okay. That then gives me all the information I need to graph the circle, because it's going to have center at 6, 4 and a radius of 5. So let's get that out there. Here we've got 6, 4, and let's see if I can count correctly this time. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And let me move my compass. 1, 2, 3, 4, 5. All right, I want to be very, very careful, especially given the fact that I can tell right away that my intersection point is not one of those 4. Right, I want to be very good about now drawing my circle. See, I told you I'd do it right the second time. Okay, so now we have our circle. Maybe we want to label it with its equation. I'll do a little line like this, and I'll have x minus 6 squared. That doesn't look like a 2 squared. Plus y minus 4 squared equals 25. Always label the things you graph. We have an intersection point right here, an intersection point right here. So my final solutions, my final answers are the point 2, 1 and the point 9, 8. And that's it, right? So a little system here. You could certainly be expected to do that in geometry, right? Because we know how to graph a line, we know how to graph a circle, and then we just find their intersection points. All right, let's wrap this up. Now today, really, the only thing that we did new was review and then I said review, right? But review how to use completing the square to put a circle that's not in standard form into standard form so we could find its center in the radius. Now, pretty much always, you have to do that by completing the square twice, once on a binomial involving x and once on a binomial involving y. I do have some on the homework where you only have to complete the square once, and I think that you'll recognize which ones those are. There are some complications that can get thrown in, like fractions here and there, or the harder one maybe, is when the coefficient on the x squared and the y squared is not equal to 1. But that's easily taken care of by just dividing both sides of the equation by whatever that coefficient is. All right, get some more practice on this on the homework. For now, I just want to thank you for joining me for another geometry lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.